Well, welcome everybody to GeoHug. So before we kick off today's session, I'd like to take this time to acknowledge the traditional lands which we're all coming from today. I live on the beautiful lands of the Gadigal of the people of the Aurora Nation, and I'd like to pay my respects to the elders past, present, and future. And yes, I'm very excited that we have Anna Fonseca joining us today. So Anna is a consulting geologist with over 30 years of international experience in regional to property scale structural and alteration geology mapping and 3D modeling, interpretations of remote sensing data in mine to greenfields exploration, and various hydrothermal deposit styles, with a focus on porphyry-epithermal, carbonate replacement, skarn, and IOCG styles of mineralization. And it is going to be brilliant getting her insights today as she chats to us about Emerging Asia Metallogenic Belts. So this is going to be a fantastic session. I hope you all enjoy it. And yes, thank you so much, Anna, for joining. It's wonderful having you today.
Thank you.
Before we do get started on your presentation, I was wondering what got you into geology to begin with.
I don't remember how I got in geology, but I remember that when I did choose to study geology, I had no idea what I was getting into.
And what have been some of your, with over 30 years experience, I'm curious of some big highlights for you.
Oh, well, Asia has been a big highlight, but there's been so many different parts of the world. Just every part of the world is different and interesting and fascinating, and opportunities to travel everywhere. So I love it, and every year I love it even more.
That's awesome. That's so good to hear. And did you bring any pet rocks with you today to show and tell?
No, I'm not a collectionist, and I'm nomadic. So I live right now, I'm here in Almaty, but I also live in Canada and live in Istanbul, and so I cannot collect rocks because usually I have nowhere to leave them.
It makes it much more challenging for you. Yeah,
I do have a small collection in my Toronto home, but not here in Almaty.
No, that's awesome. Well, yeah, thank you so much for joining. It's so wonderful having you here today. If you want to share your screen and we'll get started.
I am the VP for Regional Affairs for Central Asia for the Society of Economic Geologists. And with Jeff Hedenquist, we prepared this presentation on the Emerging Asia Metallogenic Belts. This is Emerging Asia. It's about 16% of the explorable landmass of the world. It includes over 40 countries with a variety of geological ages and rock types, and practically all types of mineral deposit styles. I'll be showing through the rest of this presentation this map, but I will remove the country names, but leave the boundaries for references, the international boundaries. So starting with the oldest rocks in Emerging Asia, we have the old stable cratons that are shown here in pink. And in between them, we have convergent margins, and those are mountain belts that formed by the collision of these old stable cratons with the Himalaya plateau. It will expand the alpine extending from Turkey through the Himalaya plateau. That's the one we see here on the cartoon, in between the Indian and the Tarim Yangtze China cratons. And in these collisional zones, we have sutures that are the remains of the collision, the evidence of the collision. And and within those collisional zones as well, we have a variety of magmatic belts of different ages that we can, from the geochronological and geochemical research that's been done, we can break them down, group them into a series of suites or ages. We have the current volcanic arcs And here's some examples in Southeast Asia. But if we look at the tectonic setting of the ore deposit types that we have throughout Eastern emerging Asia, we can break down the deposits into four main tectonic settings. The rift stage, where we have subaqueous VMS and clastic-dominated SEDEX type deposits forming at the seafloor. But we also have farther down in the crust, deeper in the crust, in this extending crust, we have layered chromium, nickel, copper, PGE deposits, and some other types of alkalic deposits. Then we have the rift state, the oceanic stage, where the ocean crust is well developed and long, and in the spreading center in that oceanic crust, we get VMS deposits, subaqueous again, and in the passive margin side, towards the stable craton, we get sediment-hosted mineralization styles, particularly base metals. Then in the convergent state, once that polarity is inverted and we start to subduct crust, we get orogenic deposits above the subduction zone. In that compressional environment, we get the porphyries forming above the subduction zone, but we still have a spreading center forming VMS in the oceanic crust. We can form porphyries and orogenic gold deposits in the collisional belt above subduction between oceanic and oceanic crust. And finally, in the collisional stage, we get we put the suture where we form the suture zone where we currently have the map, and we in place the lithium pegmatites and porphyry copper moly deposits. And so here, let's look at the major tectonic domains for not just Central Asia, for all of emerging Asia. These are again in pink, the old stable cratonic crust. In yellow, this is the Tethyan collisional belt. That is the alpine collisional belt in Europe, extending all the way from Turkey to Southeast Asia. And then we have in the north, the Central Asian orogenic supercollage, chaos. And in the east, we have the current Pacific Ocean domain. And if we look at the suture zones, we see a big difference between the suture zones of the Central Asian orogenic supercollage, the chaos. And chaos is a nice name because it does seem pretty chaotic. They are very warped, folded and refolded suture zones, particularly when we compare them to the Tethyan suture zones, which are much more linear and straight and very continuous all the way from Turkey. We can pretty much follow them all the way to Southeast Asia. In the Central Asian orogenic supercollage, it gets a lot more chaotic. But thinking of those suture zones and the magmatic arcs, if we plot the porphyry copper gold deposits, we see that they follow very well along certain specific magmatic arcs and certain suture zones. The largest deposit in emerging Asia being the Kalmakur in Uzbekistan, but a series of other large ones throughout emerging Asia, particularly in the Southeast Asia. And if we look at this Southeast Asia arc, the Indonesian arc, we see volcanoes. Even just looking at the topography, we see a chain of volcanoes, active volcanoes that are pretty evident from the topography. And these are mountain volcanic edifices like the Merapi, Bromo, Vien. And they are aligned more or less along this axis of active volcanoes. But just to the south of this axis, there's another axis of the Miocene, partly eroded, extinct volcanoes. And those are the mineralized ones. They don't have a very prominent topographic feature like the current ones, but they do have some pretty good copper gold deposits in them. And the interesting thing is that if we plot the known prospects, the porphyries, the deposits where there's known mineralization and lithocap alteration associated with porphyry deposits, we see that just about every one of these current volcanic edifices has to the south has its Miocene counterpart in either mineralization, known mineralization, or a known alteration associated with mineralization. So that periodicity is very interesting. We need to think of that when we translate the porphyry environment from the Tethyan, which is long and continuous suture zones, to the Central Asian orogenic supercollage, the chaotic, warped and folded and refolded porphyry belts of Central Asia. So again, some of the copper deposits. And now moving on to the epithermal gold, they pretty much mimic the location of the main porphyry deposits, with some of the largest ones in Southeast Asia, but also some pretty significant ones in Central Asia too. Other types of gold deposits, we have the sediment-hosted ones, what's shown here in cyan. These are from Carlin type deposits. These are from Doug Kerwin's publication, this areas of high potential. We also have volcanogenic massive sulfides that are very gold rich. For instance, here in Kazakhstan, the reader of VMS has quite a bit of gold. But the big star in my mind, the most exciting belt gold-wise in emerging Asia is in this area here that we're going to be focusing in. That's an orogenic gold belt, the Tian Shan belt. So zooming into there, this is the Kazakhstan here, Uzbekistan, this country here. Uzbekistan has a big portion of the Tian Shan, Kyrgyzstan over here, and then it goes into China. And the Tian Shan Mountains, or the Tian Shan geological belt, can be divided into 3 geological units or subunits, with the magenta one, the South Tian Shan, representing the highest elevations and the most deformed rocks. And they also, this Southern Tian Shan also hosts the giant gold deposits like the Kumtor and the Muruntau. The Tian Shan is an arcuate east-west trending belt, but right around here in the border between Uzbekistan and Kyrgyzstan, it tends to it changes into a horse-tailing set of east-westish strands of that very deformed rock, which hosts some deposits that are fairly large. Like Kokpatash, for instance, almost 9 million ounces of gold, but in the shade of Muruntau, they seem dinky little things. But each one of these horse-tailing strands of the Southern Tian Shan, towards the west, they disappear under the sediments, unconsolidated sediments of the Ural Sea. So we're not quite sure where the Tian Shan ends or where it bends, and along with the rest of the geology, because from north of the Ural Sea, everything tends to trend north-south. Now on to sediment-hosted copper. Here in Kazakhstan, we have two very important basins, the Shu-Sarisu Basin, which is quite large, well-preserved sedimentary basin, and it hosts the giant Jeskazgan sediment-hosted copper deposit. We have some there's some in China and Afghanistan and in the Kenai Peninsula. But also here in Kazakhstan, we have another large and well-preserved sedimentary basin of the same, it's really the same basin, it's just arcuate basin, like so, and separated by a belt, an orogenic belt in between. And this is the Tengiz Basin, which has a number of sediment-hosted copper showings and minor occurrences and showings, but no published resources. But beyond that, that basin extends, these rocks extend towards the east in a series of fold and thrust belts, where the basin is no longer well preserved. It hasn't received anywhere as much exploration, but there are mines, there are sediment-hosted copper mines, small local mines. So that mineralization is there, and I imagine it will, in the next few years, we will see more and more happening in this area here, and that those extensions of those sedimentary basins. Outboard of those sediment-hosted copper basins, hosting basins, we have other sediment lead zinc deposits, VMS, MVT. Some of the important ones here in the Central Asia, the Jairem VMS, Glencore's deposit just outboard of the Shu-Sarisu Basin. But in these sediment-hosted lead zinc deposits, the big star is the Mediabad Mississippi Valley type carbonate-hosted deposit in Iran. But also a series of large ones in even in the Craton in India. And now we go on to the critical minerals. We cannot have a presentation, a geological presentation, without talking about copper and nickel and the battery minerals. So the critical minerals, if we look at the nickel chromite and nickel copper PGE deposits, we see that they line up fairly well along those major suture zones, those chaotic ones in the chaos in the Central Asian orogenic supercollage here in the north, and those more linear ones in the Tethyan, with Indonesia being the biggest producer. Now, the interesting thing is they line up along the orogenic, aligned along the suture zones, but what we've talked about earlier on is that these nickel copper PGE chromium deposits, they form in layered igneous complexes deeper in an extending crust. So why do we have them along these suture zones, lined up fairly well along the suture zones? Because of course in the suture zones we have subduction of the oceanic or continental crust, but we get abduction of lower parts of the crust, and those lower parts are brought up to the surface to areas that are now to elevations that are mineable. And when I talk about podiform chromite, chromium, nickel, one of the areas that jumps to my mind right away in emerging Asia is the Ural Mountains. So we'll focus into that rectangle on the upper left there. Here we see Russia, which is not part of emerging Asia because it is considered emerged, but we see the Ural Mountains going into Kazakhstan. It's the Urals are a north-south trending mountain belt, mountains in Russia, there are hills here in Kazakhstan. It's been mined since the Bronze Age, and a series of archaeological mine sites throughout the Urals. Where in Russia, the Ural Mountains the geological Ural Mountains form about 2% of the Russian landmass, but it accounts for over 20% of Russia's metal production. So that's a very rich piece of crust there. Where it goes into Kazakhstan, here's the boundary of Kazakhstan, and just south of that boundary, it disappears into this, it ends in this east-west trending map fault. Of course, that's not a normal, that's not a geological east-west boundary. It's just what we know of, or the lack of our knowledge that we have of the Urals, where it heads towards the south. There are a series of theories of whether it bends and continues to the east, but we don't quite know. What we do know is that the Urals go under the same unconsolidated sediments of the Aral Lake here. Same sediments that hide the Tian Shan belt from that comes here from the west. Rare earth elements. The cratons are the most interesting areas particularly for pegmatite-hosted rare earth elements, but there are some Tethyan ones in Turkey, in Iran, Armenia, Azerbaijan, and Georgia, and some large ones here in Vietnam, which are the extension, down here in Vietnam, which are the extension of the Chinese belt. And now going on to lithium, just a few stars on our map, and partly because the lithium exploration, the big campaign in lithium exploration is fairly recent, and here I'm only using public data sources. So a lot of this recent activity hasn't made it into public data sources as deposits with resources. What we have in emerging Asia that is very impressive and huge is the lithium brine in Iran. That's a fairly recent discovery and blows everything else out of proportion. But in brines, we also have a discovery in Kazakhstan, which is not as impressive in terms of size, but a Canadian junior oil exploration company was drilling a well north of the Caspian Sea here in Kazakhstan and intersected lithium brine in the well and got permit from the government right away to recover that. But we also have hard rock lithium deposits, the Shavasai being the most prominent one here in Uzbekistan, right by the border with Kazakhstan. So in conclusion, I've shown a lot and talked a lot about the complexity of these suture zones, the difference between the sutures and the Tethyan and the Central Asian orogenic collage, the complexity in the ages and the distribution of the magmatic arcs. Complexity, but besides that complexity, there is a lot of potential. And that is what I want to show you to conclude. That's what I want to leave you with in conclusion. If we take copper as the thermometer for a variety of other elements, a variety of other metals, first because copper usually is accompanied by gold, moly, nickel, other metals, but also because it's a critical metal that we have a tremendous, we're facing a shortage around the world. And if we look at the current copper production, all of Asia, this is not just emerging Asia, this includes China and Russia, which are big producers and are not part of emerging Asia. It currently produces its current production is not really that, the currently known deposits in Asia are not very impressive compared to Latin America, the Andes, and North America together. But if we take into account the undiscovered copper deposits, where are going to be the copper deposits in the future, then we see Asia overtaking, Asia's share being larger than the Americas together. Now, what do I mean by undiscovered deposits? It's not something that I'm making up. This is an assessment of undiscovered deposits by the USGS, a global assessment. And if we look at that map, in more detail. Here we have, of course, in South America, in the Andes, the giant deposits are going to continue to be discovered according to this assessment by the USGS. They will be there are still discoveries to be made in South America, but if we look at where a lot of the color is, it's the most colorful area of the map is really emerging Asia, meaning that we have large tracts of lower tonnage deposits that we will be able to mine in the future in emerging Asia. So now putting that back into the map that we've been looking all along, these are the colors of just the higher grades, the higher tonnage deposits, the bigger deposits. And there are some surprises. For instance, here in Mongolia, we get for copper one of the richest areas according to the USGS in terms of undiscovered deposits is in the north rather than in the south in the Oyu-Tolgoi belt. So some big surprises here. So I hope that with that, I gave you a good idea of these vast opportunities, some of the hidden opportunities hidden behind the shadow of the active volcanoes, some hidden beneath unconsolidated sediments, waiting for us to explore. Thank you.
Thank you so much. That was brilliant. Yeah, really, really grateful for your time. So thank you.